Let's talk about quadratic equations. One of the big ideas of mathematics is this idea of the thing called polynomial. These are things that look like ax squared plus bx plus c equals 0. And this is a quadratic polynomial because the highest exponent is 2. So this would be called a quadratic equation. And a polynomial, though, could have all sorts of things. There could be x cubes, x to the third, x to the fourths, x to the fifths, and so on, all up here. But we're just talking about the quadratic ones. It's a fact in math, not that we really talk about it too much in this class, if at all, but any equation that you like can actually be modeled by a polynomial one, which means that anything in the world can be polynomial. You just have to have a big enough and long enough polynomial equation and stuff like that. So if you were to go on to calculus, we would start to delve a little deeper into that, and it wouldn't probably be unless you went into advanced graphics modeling that you'd see that. But anyway, it's there, and that's one of the reasons, I guess, in trying to convince you there's a reason I'm having you study polynomials. It's useful. To solve polynomials, there's two big things that we do. One is called FOIL, which stands for first, outer, inner, and last. And this is what we do when we deal with something called factoring, and I've used that word before in this course. And this is the fast way. This is faster. This is sort of the shortcut. If you see what to do, then you can figure out how to solve some quadratic equations by factoring. There are about like 50 different methods of factoring, so I'm going to do the one that's based on this FOIL idea. It involves a little bit more artistic type math than perhaps anything precise. But at the end of the day, it's just as accurate, and it's no less accurate than any of the methods you might have learned from some other class or section. Feel free to use whatever factoring method you like and already know. This is the one I choose to talk about because I don't want to teach 50 different ways to do the same thing. Then there's the one that always works. This is sort of a nuclear option, though. It always works, but there's some risks to it. And this is when you've got a quadratic equation like this and you're trying to solve it for x, just like we were trying to solve the linear equations for x. You have this thing called the quadratic formula. And the quadratic formula says that what you do is you take the number in front of x and put a minus in front of it. Then we do both plus and minus. We're going to get two answers because there's x squared, so that's going to give us two answers. So I'm going to have plus or minus b squared minus 4 times a times c, all divided by 2a. And this will give me two answers for x, one from the plus part and one from the minus part. As you see, this is a little bit more gnarly because it's got a square root here. We've got the plus and minus. We have to make sure that I've got the entire equation here on the left side of the equal sign, all equal to 0, and then we solve it. And so that's what we're looking at. So first of all, let me just remind you what FOIL is and what it deals with. We're kind of supposing you've seen this in another class maybe. Let's take x plus 2 times x minus 7. Well, for this equation, when I do deal with FOIL and I'm doing this multiplication, what I'm really getting myself is I multiply the first two parts together. So this gives me x times x, which we use our exponent notation to call x squared. Then I multiply the outer parts together, so I get negative 7 times x. I multiply the inner parts together, and that gives me plus 2x. And finally I multiply the last two parts together. 7 times 2 gives me 14, and a negative gives me negative 14. Then I combine like terms. X squared negative 7 plus 2 gives me negative 5x minus 14. So that's where foiling comes from. This idea of reverse FOIL and undoing this FOIL business to factor is all about taking something that looks like this and breaking it apart into pieces and going back up there. The last time I used the word factoring, we used it in a situation like this, where I had 4 plus 6, and I said, look, this guy has a 2 in common and this guy has a 2 in common, so I can pull a 2 up front and rewrite this as 2 times 2 plus 3, and then I would have talked about distributing this through to get myself back to the 4 plus 6. So factoring has that idea that I want to pull something out in front of the equation, and I'm doing that with this x squared minus 5x plus or minus 14. So here's what I'm trying to factor. When I'm trying to factor, I know some things based on this FOIL process. First of all, whatever's in front, here it's an x squared, is going to have 2 copies of itself. One x here, another x here. Next, I look in at the pattern of the negatives and my positives. Here I've got a minus, here I've got a minus. The FOIL process promises me this. I got this last piece here by multiplying the last 2 parts together. So the 2 numbers that I put here have to multiply together to give me 14, and they have to multiply together to give me a negative 14. That means one of them has to be positive and the other has to be negative. Secondly, these numbers in these spots have to add together to give me a negative 5. When I add the positive number and the negative number together, it's going to give me a negative 5. So I'm going to put the bigger number here, and I'll put the smaller. So the big one goes here, and the smaller one goes here on the positive side. Lastly, I do something that we did back in Chapter 5. I find myself the factor tree for 14 to figure out all the possible ways I can multiply things together to give me 14. So 14 can split into 2 and 7. So I can build up 14 by doing 1 times 14, or I can do 2 times 7. Either way, I get 14 out of this. If I try to pick these two and put a 1 here and a 14 here, 14 times 1 will so much give me negative 14, but when I do the O and the I part of FOIL, multiplying the inner and the outer parts, I'm going to get negative 13 here, and that's not what I want. So instead, I'm going to ignore this part, and I'm going to go with the 2 and the 7. And it's that 2 and that 7 that get me the final answer I'm after. And of course we expected that because we already knew what this was at the beginning. So before I give some practice things to factor where we don't already know the answer, let me give you the pattern. I've got ax squared plus bx plus c. If these are both positives, then when I factor this, and let me just pretend for a moment like the number in front of x squared is 1. If they're both positives, then I'm going to have both positives here. I had a positive in my second spot, which meant when I multiplied these last 2 pieces together, it gave me a positive. I could also have 2 negatives, because of course negative times negative is positive. But the fact that this was positive here tells me these are both have to work out positive. Next possible pattern, I could have x squared minus bx plus c. Well, in this case, again, you know you're going to have the x's out in front. Because this is a positive, I know I have 2 options. It's either plus or minus here. But because this one's a negative, I have to get negatives in this mix somehow. And so that means I can't have the positives. Has to be 2 negatives. Negative times negative, when I do the last 2 parts together, will give me the positive I'm after for that last term. But when I do the inner and outer terms, it's going to be 2 negatives. Next, I could have x squared plus bx minus c. Well, here I'm going to have x and x, and then I have my last 2 terms that I'm going to fill in here that multiply together to give me c. Because this last term is a negative, I know one of these has to be negative, the other has to be positive, because only a positive times a negative can give me a negative. However, because this is a positive b, I know I'm going to put the big number in the positive part and put the smaller number in the negative part, so that when I add them together for the O and I part of FOIL, it's going to give me out that positive answer. And lastly, we have one like the example we just did, where we had x squared minus bx plus c, minus c. Again, because of that minus c, I know there's going to be a positive and a negative, but because this inner part here is going to be a negative, I know that I have to put the big one with the negative side, and I put the small one with the positive side. So having said that and given us that information, let's look at factoring these 2 quadratic equations. I've got x squared minus 3x minus 18. And then for my second one that I'm going to do, I have 6x squared plus 19x plus 10. Let's look at this one first. I look at 18 and I look at my pattern. These are the two parts I focus on. Because both of these are negative, I go up here and see where I've got my pattern when I've got both of them negative. That's what I've got going here. Since they're both negative, that tells me that I have a positive and a negative. So I know when I pull this apart into pieces, I've got x and x, and I've got a plus and a minus. Because this one's negative, I know I have to have the plus and the minus. Because this part's negative, that tells me that the small number is going to be my positive. So this is going to be my smaller. And whatever goes into this blank is going to be the big one. How do I figure out what those are? Well, I take the number 18 and I see how it factors. It could be 1 times 18. I could have 18, and this could be 2 times 9. I can get 18 by talking to you about 3 times 6. 4 and 5 don't divide 18 evenly, so I don't worry about them. And from there on out, it would be 6 times 3, 9 times 2, and 1 times 18, so I don't need to factor it into any more pieces. If you wanted to look at your factor tree, you'd probably pull out a 2 and a 9 here. And then you'd know that you could pull out 9 into 2 pieces of 3. So you know your possibilities are 1 times 18, and then you could have the 2 times 9, or you could have a 6 times 3. These are the ways you can build up your multiplication of 18. I look at all of these options, and remember what I'm trying to get here. I'm trying to get a negative 3 as my inner term. All of these guys multiply to 18, so any of them would work in terms of the last term, so we go away from the last term. We stop looking at there. I need to figure out which one of these guys would add together, making the bigger one negative. And since I already know the bigger one's negative, I can go ahead and make the bigger one negative. When I do these different subtractions, which one gives me the negative 3 that I'm after? Well, 1 minus 18 is too big. 2 minus 9 again is too big. It's 3 minus 6 that gives me the negative 3 that I'm after. So I put the 3 and I put the 6 there. And this gives me my factor answer for this guy. So I have x plus 3 and x minus 6. Let's look at this one. This guy's got a little more going on for him. 6x squared plus 19x plus 10 equals 0. Again, I'm going to pull it apart into pieces because all of these are positives. I go back up to my pattern and see that means that my 2 possible answers are going to be positives here. The difference here is what's happening with this term in front. I've got myself a 6x squared. Because of that, I've got just a little bit more going on here than happened in the first one. So let me erase some stuff and give myself some space and room to work. And as I'm doing this, I want to be thinking about some things. Because I've got that 6 in front, I'm going to have 2 sets of factoring. First of all, whatever's in the last 2 spots, I know there's double pluses because of the pattern here. There was a plus and a plus, so I know that much for sure. And because of this x right here, I do know there's an x and an x here. The deal is the blanks. There's some number in front of this x, there's some number in front of that x. Then there's a number here and the number here. I have to fill in the blanks, and I have to fill in the blanks correctly so that things multiply in the front parts to give me 6, multiplying these latter parts to give me 10, and finally whatever combo I get has to add up with the O and the I part of FOIL to give me 19. So let's look at how I can deal with 6. Either 1 times 6 is 6, or 2 times 3 gives me 6. So the numbers I can fill in on this spot are either the numbers 1 or 2. The numbers I can fill in here are going to be either 6 or 3, depending. For 10, well, 10 can either be 1 times 10, or 10 can give me 2 times 5. I have to try all of these together to figure out what's going on. Here's my trick, and this is why I call it artistic. You'd have to try all sorts of things, really, to see what's going on. But here's my trick to try to make it as efficient as possible. Look at this 6, look at this 10. If I add those up together, that gives me 16. 16 is very, very close to the 19 I'm after. That tells me I'm going to take the smallest break apart of these that I can find, rather than these big ones that would give me 10s and 6s. So I'm going to pick 2 and 3, because I can do that. I can pick any direction I want right now. These are both the same, because if I put the 3 here and the 2 here, remember, 3 times 4 is 4 times 3. You can go back and forth. But once I've picked the 3 and the 2 and put them where they are, now I have to be super, super careful about this 2 and the 5. If I put the 5 here, that's going to give me, on my outer multiplication, 10x. If I put the 2 here for my inner multiplication, that's going to give me 6x, and that's not big enough for the 19 I'm after. So instead, I'm going to have to be putting it like this. That gives me, for my inside part, 15x, and for my outer multiplication, that O part of FOIL, it gives me 4x. And it's these two that add together to give me 19. So my final answer here would be 2x plus 5 times 3x plus 2. The way you see if you've factored correctly is you try FOILing. Multiply the first parts together, 6x squared. Multiply the outer parts together, plus 4x. The inner, plus 15x. And finally the last parts, plus 10. Then combine like terms and make sure that you got what you started with. If you didn't get what you started with, then you've made some choices wrong. I call this artistic because I'm working on a little bit better than guesswork. For me, it's years of experience now because I've taught this class like 25 times. But for you, it's practice. Practice, practice, practice is how you figure out how to factor these out. At this point, you're probably asking me, because let's face it, you had lots of options here. Let's look at one of them. You could have just as well chosen to do 1x plus 10, 6x plus 1. That would have given you the first parts in the way you wanted, and it would have given you the last parts the way you wanted. If you do the first part, the f part of FOIL, 6 times x gives you 6x squared. If you do the L part of FOIL, that's going to give you the 10. It's on the inner part that it messes up. For the inner part, I've got plus 60x, and for the outer part, I just have plus x. So this gives me 6x squared plus 61x plus 10. And 61 is so much, not 19. So you have lots of options. You've got several options. This is the only pattern, though, that's going to fit together to make it work and get you your correct answer, which is this one. This is the correct answer for this original quadratic equation. To get that correct answer requires a little bit of insight, a little bit of practice. I said for me, practice because I've taught the class 26 times. For you, practice because you're going to work on a lot of the homeworks. But what if the practice doesn't work? Well, some of you probably have some clever techniques. I've seen some people do clever things. I don't know, they write different numbers in these and get something else. Some of you who've taken the 300 series with Miss Lowe have what I've heard called the Lowe method. That probably works too, and by probably I mean it does. I don't know it, but I've seen it work, so it must work. But all of these things are just different tricks that would help you have some insight, and it would be an artistic answer. If you want the for sure way of solving things, you're stuck with our nuclear method, which is the quadratic equation. Minus b plus or minus the square root of b squared minus 4ac all over 2a, where this would be my a, this would be my b, and this would be my c. So when you're looking at quadratic equations and you're trying to solve them, if you can't see how to factor them, then you go to the quadratic equation. So let me work an example of something that needs to use the quadratic equation to have it happen. So let's take x squared minus 3x minus 18 and plug them into the quadratic equation. First of all, let me point out some things. Here's one form of this equation. This is another form that's the same way, because I could have subtracted 18 off both sides of the equation and got myself right back to the x squared minus 3x minus 18. So you've got some different formats that it could be in and looking like. Or I could have had one of the x's factored out in front. All of these would lead you at the end, once you did some algebra, to this equation. So let's talk about my pieces. Here's my a, it's the constant coefficient 1. Here's my b, it's the number -3. And here's my c, it's -18. If you had this version of the equation, you couldn't pick c as 18 because c is not 18. c is -18. And you see why that has to be from here. Next, I plug these pieces into my quadratic formula. So here, let me grab my quadratic formula from up here, and let's haul it down. Alright, so let's start to fill in the pieces. I know that a is the number 1. I can be picky if I like and put little parentheses with 1s in there. I know c is the number -18. And I know that b is the number -3. Now I start to do some algebra. Negative times a negative gives me a +3. I've got plus or minus. 2 times 1 gives me 2. I've got my square root. -3 times -3, because that's what -3 squared means. 3 times 3 is 9. Minus minus gives me plus, so I have +9. Here I've got 4 times 1, so that just gives me 4. And 4 times 18, maybe I'll multiply it out. 8 times 4 gives me what, 32? And 4, 5, 6, 7 gives me 72. But remember, minus minus again gives me plus. So I've got 3 plus or minus the square root, 9, 10, 11. This gives me 81 all over 2. This gives me 3 plus or minus. I know what the square root of 81 is. It's 9. And now I have my two possibilities. I either have 3 plus 9, which gives me 12 over 2, or I have 3 minus 9, which gives me -6 over 2. This gives me an answer of 6. This gives me an answer of -3. So either x equals 6 or x equals -3. But remember something. This equation, x squared minus 3x minus 18, was one we'd already worked up here before I erased things to solve this format of it. Remember when we factored it before, we'd gotten this answer. We'd gotten the answer x plus 3, x minus 6 equals 0. We've got this rule in math. It says if you multiply two things together and they equal 0, either the one thing equals 0 or the second thing equals 0. So if I have x plus 3 times x minus 6 equals 0, that tells me that either x plus 3 equals 0 or x minus 6 equals 0. If I subtract 3 from both sides or add 6 to both sides, that tells me x equals -3, or that tells me that x equals +6. And that's how these two things are agreeing with each other. I've got this link between them. And that's based on this fact that if you're multiplying two things together and they equal 0, no other number works like this. They have to be multiplied together and it has to equal 0. Then you get this two possible equations solved. So that's how the quadratic equation and this factoring business are the same. Here's generally what you do. You use factoring if you can kind of already see what the answer is, if there is an obvious solution. And what's obvious to one person is not going to be obvious to another person. Again, the more practice you do and the more experience you get, the easier things are going to be to solve with factoring, because you're going to know more and more solutions and have more and more skill at seeing that. And this is faster. So the more practice you do, you're helping yourself in your terms of your solving equation speed. On the other hand, if you don't have something else, then you can use yourself the quadratic equation. That was some horrible grammar there. You can use yourself some quadratic equation. Wow. Anyway, you can use the quadratic equation, and this is a little bit longer, but it will give you an answer. It's always guaranteed to give you an answer. And the relationship between these two things is this one we've seen here. It all depends on this fact.